Okay, for today, the next unit is going to get into graphing polynomials. And the most important thing that we're going to talk about is getting to know kind of how the end values go. And like that's the biggest thing. And then knowing a little bit of terminology, like if I asked you what the multiplicities of the zeros were, you might not know what either of those things is. So let's go back to just basic. Everybody write this down, please, on your blank notability doc. X plus 3, x minus 6. Would you please just make a sketch of that? The reason you factor it is to find the x-intercepts. You should be able to find the x-intercepts in like a few seconds. Boom, boom. You know what the graph looks like. I hope by now you know this is x equals negative 3 and x equals positive 6 because that's what makes it equal 0. They're also known as the zeros. Okay, so negative 3 would be like here, and 6 would be like there. And so I'm going to put a dot at both of those. And now the parabola kind of looks like that. How do I know it's not upside down? There's no negative in the front. Do you remember that deal? If there's a negative in the front, the right side would have to be down. And since it's a parabola, both sides would end up being down. All right. So what we do when we have more complicated graphs, like y equals 3x to the third plus 2x plus 8 or whatever, that's a more complicated graph. But it still comes down to these x-intercepts end up being super important. So I know since this one has a positive number in front, everybody make a quick sketch, and all I want to know is does it kind of look like this? Or does it kind of look like that? Is it up on both ends? Is it down on both ends? Is it up on the left and down on the right? We reviewed that. I'm hoping that's going to be easy for you. Negative. There's no negatives in the whole thing. Okay, Mr. Long, right end. I'm sorry, Brady. What's on the right end? Is it up or down? It's up on the right because of this being positive. Left end, really what we decide is it the same or different? Mason, this tells us. Is it the same or different? It's different, so it must be down over there. Now, how it touches, like does it touch here and then go through there? That's determined by if it's factored. Now, this one's not factored, so I don't know. I don't know about the middle. All of this in here, I was just guessing. The only other thing I could know for sure is that this is called something. Do you remember what that's called? How about this? What if I asked you, is that the x-intercept where y is 0? Or is it the y-intercept where x is 0? Well, if I put in x is 0, do you get these two would knock out if x was equal to 0? Then you'd get y equals 8. So if x is 0, you got the y-intercept. So y equals 8, that's the y-intercept. I'm reminding you about all these things because you're going to need to know them. So when you're asked a question like this, what's the y-intercept of this thing? All you got to do is put in what? What did I just say? 0. X equals 0. I just put a 0 here and I put a 0 here. Does that mean the answer is 0? No, it means you figure it out from there. Now in this case, 0 squared is 0 times 0 plus 2 is 2 to the third. Doesn't the 0 end up multiplying and everything turns into 0? Yeah, y equals, and that would turn into 0. The x-intercept is where y equals 0. The x-intercept, this is the y-intercept. So we wanted x to equal 0, and then we figured out what y was, and y was also 0, so it's 0, 0. Now another question they can ask you is about multiplicities. Multiplicities are these little powers. This has a negative 2 as its root, also known as its 0. So the 0 is negative 2. I know, 0 is a weird word, but we got to get used to it because they're calling it the 0. It's the same as the x-intercept. So the 0 here is negative 2. It's the thing that would make the equation 0. Isn't there another 0? Yeah, in the front. What would make that 0? If I put in 0. So x equals 0 and x equals negative 2 are my two zeros. They would make the equation 0. That's why they're called zeros. So one of the zeros is negative 2, and one of the zeros is 0. I know that's confusing because I'm calling 0 two things. But the zeros are the same as the roots, the same as the x-intercepts, and they're the things that make the equation equal 0. Okay, and now their multiplicity? Their multiplicity is just the power that is above them. So like right here, that has a multiplicity of 2. Couldn't we just call it the power? Yeah, you actually could. But we're going to call it the multiplicity, and you have to know what we mean. So that one was the one where x equaled 0. That was the 0, also known as the x-intercept, also known as the root. And that root has a multiplicity of 2. So this one here had a multiplicity. I'm going to shorten it to MPY. Would you agree MPY gets across a multiplicity without having to spell a ridiculously long word? Okay, so then MPY was 2. If you understand patterns, you probably get then that this is the other 0, and that must be its multiplicity. MPY 3. Now, a quick reminder of what they do. The even kind bounce and the odd kind pass through. Do you remember doing this in higher algebra? I know you had it in higher algebra. Whether you remember it is the question. You remember this deal where sometimes they'd go like, they'd pass right through. Let's say this is at 3. Let's say this is at 7. And then here's at, maybe it's negative 7. That's the only one where it bounced. The other roots, which are these green dots, they're also known as the x-intercepts, it's just passing through there. Then, this is the most important note of them all. So please copy this drawing, and I'm going to have you write underneath it. It says, because this puts it all in one place. The negative 7, the 3, and the 7, those are called the zeros, the roots, the x-intercepts. They all have multiplicities. The ones that bounce, those are even. The ones that pass through, those are odd. This has to be even. This has to be an odd one. And this has to be odd. And what I mean by that is the power on it has to be odd. So the equation for this graph would be a parentheses here, x plus 7. Remember that deal where this is the opposite of what you would think? It's a negative 7. Another way to think of it is negative 7 makes it equal 0. And I said it had to be odd. So we're just going to put it to the power of 1. That's the most common odd number. Would you agree? You see 1 a lot. 3 is also odd. Could be 5, could be 7. Then we need another parenthesis for this guy. From what I just said, you should be able to figure it out. What would go in that parenthesis? Rissy, give it a shot. X minus 3. And then what kind of power do I have to have? An odd one, so I'm just going to put a 1. Could it also have been a 3? Yeah. And last but not least, make one for this last one. Mr. T, keep that phone away, please. I know it was making a noise and you just wanted to turn the noise off. That's fine. I know what happened there, but keep it put away at this point. Greta, can you tell me what that last one would have to be?
X minus 7.
And then to a power of?
2.
Excellent. And if I asked what the multiplicities were, these are the multiplicities. Fancy name for powers. All right. Now, I'm just going to kind of sum it all up. Here's what you're expected to know, and it's all review. Y equals negative x to the third plus 7. I could ask you, what is the right end doing? What's the left end doing? What's the y-intercept? On that kind of problem, since it's not factored, I can't ask you for the zeros, and I can't ask you for the multiplicities. Only if they're factored can you do that. But I could ask you the right end, the left end, and the y-intercept. Garrett, on the right end, is it going up or down? Down. On the left end, Iris, is it the same or different than that?
Different.
And how'd you know that?
Because the power is odd.
Power is odd, so that means different. Different than down must be up. Okay, and the y-intercept is where x is 0. If I put in a 0 right here, do you get all that would turn into a 0? And then y equaled 7. But it's a y-intercept, so make it 0, 7. A y-intercept is a dot. It's a point. So you give us, the y-intercept has an x equals 0, right? So that it's 0, 7. Okay, and then the other big kind of problem is if I give you this and it's factored, you should be able to do two things. You should be able to tell me the zeros, aka the x-intercepts, and you should tell me their multiplicity. So George, what's a 0 here?
I'm not sure.
Okay. Are you doing something else right now, or are you with me? Are you doing something else, or are you with me?
I'm just on the
All right. All right. Felt like you were on a different page or something. So come back with me, and I'll call in you again in a second. Claire, can you tell me what the 0 is for this first one? X equals 8. And then the multiplicity of this. 3, yeah. And then in a different color, I'll do the other one. X equals negative 4. But you didn't put a power here, Mr. Server. Well, then what power is there for sure? It's a 1. So the multiplicity is a 1. Then you should be able to sketch it. Because you know the right end is going up because it's positive in front. You know where it bounces and where it passes through. In fact, both of these are a pass through. So you should be able to sketch it. The last thing is the y-intercept would be really handy. The y-intercept was where x is 0. Put a little 0 here and here. And it comes out to this really big number. You just have to know if it's positive or negative. So I'll let you off the hook on exactly what that number is. But do you get, this would be negative 8 to the third, which would be a big negative number. Some big negative number times 4. Makes it even a bigger negative number. So then it's somewhere down here, and I don't even know where it is. It's just some big negative number is the y-intercept. It also passes through at 8 and negative 4. See, this one's negative 4, passes through there, and it also passes through at 8. And last but not least, I know this thing has a total degree of 4. See how I had to put that together? The total degree was 4. So then that means it's an even one. So since it's going up on the right, it must be also going up on the other end. And there's my final answer. Now, I know that's pretty intense, but I wanted to review everything from higher algebra about this topic. Okay, so if you really understood that, I should be able to just sketch this. And you should be able to go, okay, I know that, wait a minute, I'm wrong, not a 5, a 1, sorry. Because you're gonna wanna find the y-intercept and put a dot there. You're gonna find the x-intercepts and put dots there. Then you're gonna remember where it bounces. And you're gonna go remember that the right end is up because, you know, the lead number is positive. And the left end, you're gonna need to know the degree of this polynomial, which is not 2 and it's not 3. The degree is 5. And that'll tell you the left end. Then make a sketch. I'm gonna pause for a second. You see if you can put it all together. What is the y-intercept? Hint, it's where x equals 0.
0, 4.
All right, 0, because x equals 0, that's a guarantee. And now I'm gonna go put 0 over here, and this becomes 4 times 1, which is 4. Very good, 0, 4. So I go over 0, up 4, there's a dot right there. See we got that? The y-intercept is where x is 0. So we put a 0 in, we figure out that y equaled 4. Okay, the x-intercept, which is where y is 0, what makes this 0? Oh, 2 things. The x-intercepts are where y is 0, so I'm going to put a 0 there. One of them is 2 for this one. That gives you a 2. This one's -1. And I'm going to graph that. Now, is it bouncing anywhere? Yeah, it bounces at that one, which is right here. I'm putting a little B by it. You don't really have to, but I'm putting the B there to remind myself I need to bounce there. The right end is up, and then it has to bounce there, go through here, and then at this spot, and that's the bounce. Sorry, that was the bounce. This spot, it needs to hit at -1 and it needs to pass through there. I know that was tough. But basically, what I just showed you is how to do your next test. I'm serious. We covered like a ton of stuff so that this would be like an R3 level question, like a hard kind on your next test. I just wanted to show you everything up front. You weren't meant to get all of it, but do you feel like you got most of it? All right, cool. So that's what we're kind of doing for the next unit, is graphing polynomials like that. And there'll be more, of course. I'm not just going to have one day of teaching and then like 16 days of review. Next week, remember I'm gone Monday, Tuesday. During those 2 days, you're going to be doing a thing on factoring. I want to give you a small lead into that too. This is called factoring by grouping, and some of you maybe even already know it, and you're going to be like, oh my gosh, that's so easy. Everybody write this down, please. X to the third plus 2x squared plus 5x plus 10. When I taught this in higher algebra, actually, I think some of you guys never have seen this before. This is going to be brand new, but I know some other people have learned it. So this is one of those where some of you learned it, some of you didn't. So don't feel bad if this feels completely new. Maybe you never learned it. This part right here, if I factor just that, I'm allowed to do that. I can factor just that part because they both have a 2 in it? No. What do they both have in them?
X.
Yes? And even more than that, they both have an x squared. Good, so you take that out, and then what do you got left? X plus 2. Then, easy street. We're just going to factor this part. What factors out of that? 5. So you take out the 5, and then what do you got left? x plus 2. Do you think it's a coincidence that we ended with the exact same thing? No, that was set up that way, and it will always be that way. So now, the cool thing is, you factor it again. And now I ask you to look, I'm going to highlight them. The blue highlighted part and the green highlighted part. What do they have as a common factor? X plus 2. So that's the common factor. So we factor it out front. And what's left when we factor that off? And the way to think of that is you're dividing this by x plus 2, and you're dividing this by x plus 2, and you get what? Well, this canceled. This cancels. Yes, say it. Yeah. How many of you feel like you've seen that before? All right, cool. So that's what we're going to do officially, a full lesson on that, Monday, Tuesday, 11. One of the nice parts is for next week is the principal has said, and I will abide by this, that we cannot assign homework to take home on Tuesday. So you get Wednesday, Thursday, Friday, Saturday, Sunday, all completely off of math. Okay? So Monday I can assign homework, and I am. So I'm assigning homework Monday night, and hopefully you just basically crank the assignment out that I give out on Monday, and then you get it done, and in class Tuesday I practice a little bit more, and then you're done. All right. So there's a preview of what we're officially doing on Monday and Tuesday when I'm gone. I have a sub. I've worked hard to get a math teacher. He actually knows how to teach math. He is a retired math teacher, so he taught for many years. He totally can explain every problem. So, and that's all I got for you for today.